Okay, to wrap up this section in 6.2 where we've been discussing random variables and performing transformations both just on a single random variable and then combining two random variables together. If you recall, the rules for performing a transformation on a single variable, they follow the exact same rules as performing a transformation on an entire data set in terms of what's affected by addition and subtraction and what's affected by multiplication and division. Just want to highlight a couple of things down here when we're talking about combining random variables. It is of the utmost importance that when we are talking about adding random variables, please remember that we are to never actually add together the standard deviations. We always want to rework those into their variances by squaring the standard deviation and use that to add together and then retake the square root of the sum. Okay. Again, if you're ever going to do that, to combine the variances of two random variables, you must be able to come to some reasonable conclusion that those two random variables were in fact independent of one another. Otherwise, you should not be combining their variances together. Okay. If you recall, it is addition of the variances, whether you are adding or whether you are subtracting the two random variables, okay, in terms of the variance. Okay, that's because the variance always increases when you're combining two random variables, okay, even when you're subtracting them. Okay, so we always add those. However, when we talk about the means, you would subtract the means if we're subtracting the random variables. Okay. All right, so on the next page, we're going to take a look at an example here. It's going to kind of tie all of this together. It says, Mrs. McConnell likes between 8.5 and 9 grams of sugar in her iced coffee. Suppose the amount of sugar is in a randomly selected packet follows a normal distribution with a mean of 2.17 grams and a standard deviation of 0.08 grams. If Mrs. McConnell selects 4 packets at random, what is the probability that her iced coffee will taste right? Okay, so I'm going to be selecting 4 packets of sugar and putting that in my iced coffee, and I really want the end result to be that there's between 8.5 and 9 grams of sugar in my iced coffee for it to kind of taste right. Okay, so we're going to start out with the state step, which is where we kind of state the given information. We're going to let X represent the amount of sugar in just one single packet of sugar. Okay, we were told the shape is normal. The average amount of sugar is 2.17 with a standard deviation of 0.08. Okay, in the plan step, we're going to kind of run through what is it that we're trying to accomplish here. Well, if I'm going to be selecting 4 packets of sugar, and of course those are all going to get combined together in my iced coffee, each of those packets of sugar is kind of like a separate trial. So I'm going to be adding that up 4 times, and that's going to create a new random variable. We're going to call that T for the total number of sugar that I'm going to be putting in my iced coffee. So we're going to need to calculate the mean of T and the standard deviation of T. And once we have that, we then will be able to answer the probability question, which is, what is the likelihood that then my iced coffee would have a total amount of sugar somewhere less than 9 but greater than 8.5 grams? Okay, so there is the plan step. Now we're going to go ahead and follow through with the do step. Okay, we will calculate the mean of the random variable T, okay, which in essence is us adding 2.17 4 times in a row. So we can multiply that times 4 here. Okay, and that will give us 8.68 grams for the mean of the random variable T. Okay, keep in mind when we're combining together random variables, to get the standard deviation, we should technically be combining together the 4 variances. So we could string these along 4 times like that, okay, 4 times in a row, or I could simply multiply the variance by 4, and then to get back to the standard deviation, I'm going to take the square root of that. So I get 0.16 for the standard deviation of T. Okay, I'm going to put this together. The shape should stay the same as the original shape of a single packet of sugar. So the shape of the random variable T is approximately normal. 8.68 is the new center, 0.16 is the new standard deviation. And now I'm going to find the probability that the total amount of sugar from those 4 randomly selected packets of sugar would in fact be somewhere between 8.5 and 9 grams of sugar. Okay, so I'm going to put my labels under my calculator inputs here. Okay, I will draw a quick normal distribution with the center here. Okay, we are looking roughly at, we'll say 8.5 is here and maybe 9 over here. I'm going to shade the area in between. Okay, my lower bound is 8.5, upper bound is 9, center 8.68, standard deviation 0.16, and we're looking at about an 84.7% chance that my iced coffee would have between 8 grams or 8.5 and 9 grams of coffee. Okay, so we'll just kind of sum that up in the conclude step. There is an 84.7% chance or probability that the iced coffee would have between 8.5 grams and 9 grams of sugar, which means I would think that it tastes right according to that problem there. Okay. All right, the last problem that we're going to wrap up here on this section 6.2 is talking about fast food companies, and you may have actually experienced what this problem is discussing. It says the diameter C of a randomly selected large drink. Okay, so we're talking about a large drink cup at a fast food restaurant follows a normal distribution with a mean of 3.96 and a standard deviation of 0.01. Okay, so that's roughly the diameter here of a large cup lid. Okay, the diameter, I'm sorry, that of a large cup, like the top of the cup. Okay, it says here the diameter L of a randomly selected large lid at a restaurant follows a normal distribution with a mean of 3.98 and a standard deviation of 0.02. Now, if you've ever grabbed a lid and put it on the cup and it felt like it wasn't tight enough, or maybe it was too small, that's what this is referring to. It says for a lid to actually fit the cup, the value of the lid, L, it has to be a little bit bigger than the value of C, the cup, okay? So it kind of hugs around the outside of the lid of the cup there. But it can't be any more larger than 0.06 inches. Otherwise, it won't snap on and kind of feel that snug fit, okay? So it has to be larger than C, but not more larger than 0.06 inches. So the question is, what is the probability that a randomly selected large lid will fit on a randomly chosen large drink cup? Okay, so we're going to take that information that I underlined up above. We have 2 distributions, one for the diameter of a large cup, and then one for the diameter of a large lid. Okay, so there is the state step. Okay, let's look at what we're going to be finding here. Now, we need the lid to be bigger than the cup's diameter. Okay, so it kind of feels like here what we're going to need to find is we're going to need to introduce a new random variable. I'll call this D for the difference. We're going to be subtracting the diameter of the cup from the diameter of the lid. Okay, and our hopes here is that that difference is going to be a number that would definitely be greater than 0. Okay, because we want the lid to be larger than the cup's diameter. So we want this difference to be greater than 0, but we don't want it to be more greater than 0.06 inches. And so the probability that we're trying to find for D is we would want that difference to be something larger than 0, but still less than 0.06 inches. Okay, anytime we introduce a new random variable through transforming, we do have to calculate the new measure of center and the new measure of spread, and that's what we're going to do here next in the do step. Okay, so the new measure of center would be taking the lid center minus the cup center. I have to do this in the correct order here, so I'm doing this one minus that one here. So we're looking at roughly the new center for the difference is 0.02. When we calculate the measure of spread, remember, even though we were subtracting the random variables, we still add their variances together. Okay, so I'm going to add together their variances, and then I will take the square root of that sum. That will give me the new standard deviation for the random variable D. Okay, we're going to put this together. This will be normally distributed because both my random variables had that shape. And then we should be able to proceed with answering this question here using our normal CDF feature. Okay, just labeling our inputs. And going to go ahead and sketch a normal curve with the center 0.02. Okay, we're looking for 0, and we'll say 0.06 there, and we're going to be shading everything in between. Okay, our lower is 0, our upper is 0.06. There's our mean, there's our standard deviation. Looks like this would come out to, about 77.7% would be the likelihood that we would randomly select a lid that would fit on a randomly selected cup. That's kind of what our odds would be there. Okay, I believe that